Okay, so before the break, we were looking at going over a few things that had shown up in the book and trying to generalize those where they're not C# and Unity specific, because this course is game development. There's nothing in our name about Unity or C#. So we want to make sure that we can apply these same concepts if we wanted to use JMonkey or Unreal or any of our other popular engines. It would be way too overwhelming if we tried to look at all of them in a class. So we don't want to look too detailed at all of them. So as we study this stuff, make sure you're generalizing the concepts. Along that lines, there's still a lot more we can see. And well, for when we do class examples, I wanted to try to do some of the things that aren't covered in the book. And one of them has to do with how we move our characters. So the first game we made, following along the tutorial in the textbook, or prototype is what the textbook calls them, following along the prototype instructions, it used the mouse. We'd move the mouse left and right, back and forth. As the mouse moved left and right, then the game object moved left and right. The second tutorial used the either WASD or the arrow keys, use the input axis, so both of them would work. And if we plugged up a plug and play controller, that would work too. Just left our mouse unused, available. And there's some things that are fairly common, right? Like a lot of times when we'll use both. We'll use the keyboard to maybe move the player, and the mouse moves moves the camera around. So we might want to, but we might want even more than that. We might have a whole bunch of things that we need our keyboard for. We need our buttons using for something, and have our mouse moving that camera around a 3D world, which kind of takes away our first thoughts on a way to move our player around the world would be. So one alternative, which relates to our major learning objectives because they're very vague. I was at the meeting where these were written, and on this one, demonstrate fundamental understanding of AI scripting and interactions with player. I'm pretty sure we were talking about the enemy AI at that point, but it does apply here. Because maybe we have a big complicated game where we need our normal movement keys, the WASD or whatever. We need those to do inventory stuff, switching between the inventory and stuff. And we need our mouse movement. We need that to control our camera, which kind of runs us out of the ways we've seen so far to move our player. But there is sort of an AI type of movement that we can use that I thought we'd go ahead and look at that because our book doesn't talk about that. So I'm going to create a new game, which I actually have to leave this and go back to Unity Hub and make a new one. So new project. Just do another 3D one. Sure. Call it Project 3. That's a good name for it. I pulled up an example on my other laptop here that I probably should have simplified because I just pulled up a big, complicated role-playing game that has lots and lots and lots of stuff going on in it. And was thinking I could look at that. And now that I'm looking at it, I'm like, I have to jump back and forth between 2 or 3 scripts to do a simple version of this. So hopefully I won't get lost between the two, but I remember the main concepts. So alternative to those keyboard or mouse controls is we could use just some slight indications to tell the computer the direction we want to go in, and let the game itself figure out how to move our player there. What's the best route to get somewhere? Okay, so that's still set up from the last game. I don't want to use that one. Free aspect, that'll work. So we have this big world. We want to move a player around in it. 734. I'll just create our world here. So like we saw before, create an empty object, which will handle the logic, and then that can be a parent of the graphics. So I'll call this the ground, and then I'll create a cube underneath it to be the ground image. And then this we can just scale out on the X and the Z axis. You can see from the arrows. Red, green, blue arrows are kind of a standard when we're working in 3 dimensions. The order of red, green, blue follow X, Y, Z. So red is usually X, Y is usually green. Yes, a comment in the chat came up about AI pathfinding. So that's what we're going to look at, because it's a useful way to move around. And it's built into the game engine. Not just Unity, a lot of our major engines have that built in. Once somebody figured it out, that kind of became a necessary thing to include if you want to call your software a game engine. So we'll look at the one in Unity, but we have these things elsewhere as well. So we make this ground bigger by just scaling out the X and the Z. There we go. We have a nice big surface. I need some material here. I have to add a new material, don't I? I have to do it over here. Create a material. And then this material can be attached to the ground image as a component. And this one can be edited. The default one, it won't let us edit the default material. So if we add a new material, we can do things like change the color. Make our ground green. That seems a good color for the ground. But that's not really all we have, right? Let's put a player on here. Create another object. This one's going to need some logic, so make the parent object, and then on an empty, and then I'll create a sphere. That'll work. And once again, the default material, it's grayed out. We can't really make changes to that. So if you want to change the colors and stuff, we can create a new material. In 3D stuff, color alone is the color. It's more than color. We need a full material. We need to kind of say what that material is. So some color for our player. I'll make it purple. Bring it a little above the ground so we can move around. And well, like we saw before, we have free movement here. We could just go anywhere, any direction is as good as another. But we're often going to have obstacles, right? Like some sort of wall thing. Create an empty one. I'll just call it obstacle. And I'll give it a cube so that it looks like a big wall. Whoops. Wall. Once again, I'll throw some color on it. That way we don't have a bunch of uncolored white stuff on here. New material and attach that to the wall. And then we have all sorts of properties about, like we saw in over in Blender. Is it metallic? Is it smooth or rough? Does it reflect light, absorb light, all of that stuff? But really right now we just need some color. Make it sort of brownish. That'll work. So that when we bring that up, we have this nice little wall shape, which we probably don't want our player and to be able to just walk through the wall. So it's something we can actually hit. So those are going to need some rigid bodies so that physics applies. Add component. These I think everybody's seen, right? Rigid body component. I just put that in the wrong spot. I did. Let me undo that. Remove that and put it on the parent object, the wall itself. Add a rigid body, and a rigid body is the laws of physics. We don't need to use gravity. We'll just leave it where it is, but it has a mass. It should, we don't want it to move. So leave its kinematic unchecked. That way it's not something that can move, or we could give it a really big mass, say 100. And then when our player with a mass of 1 runs into it, it's not going to move the wall at all. But kind of lock it in place. I was going to keep it separate from that. We could add it as part of that and wrap things around, but I'll just go ahead and hit all the check boxes so that it doesn't move, but it exists there, and then add a collider to it. A cube collider. Should we edit? Oh, whoops. The wall got off from the parent object, so I need to set that back 0, 0, 0. And then move the parent object over there where we can see it. So if we go to edit that collider, it detected the cube there. So when we have a nice little shape like a cube, it should fill it in automatically. The same thing for our player. If we select the player object and add a component, a sphere collider, it looks like it detected that image and went right on it. So now I'm going to kind of set this in place. So it sticks a little out of the ground, enough out of the ground we can bump into it, basically. Same thing for our player. We'll leave a little bit above the ground. I guess we could apply gravity so he falls down on the ground. If we give well, I'll skip that for now. Leave our player just a little bit above the ground. So he moves around. And if we attach a quick script, we should be able to see that to use our, to run into it, just to make sure that would work. So I tried to set that up so that the same, it should just move in the X direction, and oops. Add a new component, call it player. That'll make it, not that. A new script called player. And then that should give us ways to make the player move and close this earlier stuff. Oh yeah, that's what I was started to was thinking briefly that the easiest way to make the players fall to the ground is just to give the ground the laws of physics itself. So give it a rigid body. And definitely freeze that in position because we don't want the ground moving. Everything else is going to move relative to our ground. Can we see everything here? Yeah, that'll work. And if we look at the little arrow on our player, if we move in the X direction, we should run straight into that wall and stop. So I guess now our player we can apply gravity to that. So back in its rigid body, the player has gravity. It can move freely. Rotation won't matter, it's a sphere. So if our script just kind of does that, where'd it go? Oh, over here. So like a new vector three item. I'll call it move, and that'll be a new vector three object that goes one in the X direction and doesn't change in the others. And then we'll just take our player's own transform. We can always access that we can access our own stuff directly. So transform dot position. It's better to do it through the rigid body. We should probably be doing the rigid body here, but we can change this by that move. I think that's going to work. So if we run this, oh, I missed something. What? I need to say that's a new vector 3. Okay, my languages are running together. You have to say it's a new vector 3. So it took off really, really quick. Okay, that's way too fast. So 0.0001. Let's see what this looks like. That has a collider. That has a collider. They both have rigid bodies, so it should run into it and stop. There we go. Uncheck is kinematic. So it runs into it, it keeps trying to move, but it can't go any further. So that's what we've seen. We could do that with the keyboards and stuff, but there might be a better way. It's like, how do we get to the other side of that, right? With the keyboard, that's easy. We move left or right and then go up and around it. But we want, we might need our keyboard for something else. And we probably want our mouse to use our mouse to control the camera movement. So that's where a Nav Mesh agent comes in. Let me make a couple of copies of this. So copy that and paste it. So this one can come down here and rotate 45 degrees. And this one go like over here and rotate 90 degrees. And just kind of give us some more things to move around. It wouldn't be any trouble at all with a keyboard. But if we're using our keys and the mouse already, we want the computer to figure out how to get there. The pathfinding is what it's often called, where if we're here at our player, which usually the camera would follow, we could just click this spot over here and our player will go to that spot. Or we can click over here and the player will go there, finding the best route. So what that is a Nav Mesh Agent. So we'll go to the ground and we'll add, if we start searching, we can add a nav mesh to it. Is the agent the one I want? Nope, that's the one. Oh, yeah. I remember that. It's up here. It's another panel. It's not even up here. We have lots of controls on that. So if we come over here, I usually put it right beside the inspector panel, but under Windows, and under AI is navigation. So go to Window and AI and then navigation. I always keep it right beside the inspector. And I'm almost positive I have forgot that before and started looking for components because I keep it right there. So maybe down below would be a better spot to keep that. But this gives us the things to set up. So select a mesh or terrain from the scene. So we have our ground object here, which notice it does have to be a mesh. So we have to go down to the image for it. And then we can set up different properties. So no terrains are in there. There's all the image, there's all the meshes we have. So that's the things we have to work with. We'll go back to all. Oh, I guess I have to choose it from there. So when we choose our ground image, the mesh itself, we can set up different items about this. I was expecting a whole bunch of things to pop up and they're not, I'm not seeing them. So go to that and then apply our navigation. Walkable is one. Where are all my other options? I think they have updated since the last time I did this. I'm looking at the right thing, right? Move those pictures out of the way. And scene should have some walkable areas. And there should be some highlighting showing up here, and that's what's confusing me because I don't see any highlighting available. Walkable. Show Nav Mesh is checked, but it doesn't seem to be pulling up like it should. Nope. Which option am I missing? Or did they update this? No, that's still the same stuff. Sorry, I'm suddenly forgetting something and no. And I suddenly forgetting how to get all these to pull up. So I might have to search step one here. I pulled up the code for the example on a computer that does not have Unity on it. Nav Mesh Unity. Yeah, so we should be seeing a whole bunch of things highlighted in blue. But it's not highlighting anything in blue. Select the geometry, walkable surfaces, check navigation static, and adjust the bake settings. Okay, that's what I was thinking, but it's not pulling up my options. So let me try this again. So select the ground image, and it is static. The walls are not walkable. Again, navigation static, not walkable. And I really feel like I'm forgetting a step, but so our ground set to walkable are our walls are set to not walkable. And usually that highlights in blue, but it's not highlighting in blue here for me, which leaves me a little confused. Maybe I have to apply it to the player. Let me go back to here, and our player and then the inspector, that's where we add the Nav Mesh Agent. So it gets this component that has a bunch of properties that will determine if it can walk or not. And I have no idea why this isn't highlighting things. I'll click a random video. Sorry.
I can't afford streaming anymore, so.
Sure you can. State Farm has.
In this video, you'll learn how to create simple pathfinding.
In here, we have as well as this surface component. Here we have a few different settings. Go create empty. Let's reset the transform on this and let's rename it to Nav Mesh. Let's then drag it to the top so we can easily see it. So this game object is going to be responsible for baking our Nav Mesh to make.
Oh, that might have been what I did. It shouldn't be on the ground itself. It should be an object all on its own. And that it's this. All these things are already set like they were. But it's still not. They seem to have updated things since the last time I did this. Well, I'll go over the settings real quick and see if I can remember this because I was hoping to end by 8:15. It goes really, really quick once we see it. I'm gonna click over here and see what step I'm missing. What am I missing?
I could do this, let's hit add component, and we'll add in the Nav Mesh surface component. Here we have a few different sets.
Well, he did that from the inspector. So on our empty, we need a Nav Mesh surface. Oh, that's not on here. So we set up our surface and then over here, it's still not showing anything. Sorry, I seem to have forgotten something or it's updated since the last time I did this. Let me go back to the hierarchy. So here, show that. Show the height mesh. And well, y'all know the process. Well, things run together and I've done this many times, but I seem to be skipping the
step. So this game object is going to be responsible for baking our nav. We just go ahead and hit bake. We can see that right away Unity creates a nav mesh for us. All the blue tinted areas represent.
Oh, do I have to bake that first? Under navigation, when we set that up, if we hit bake, oh, okay, sorry, I was forgetting something silly. We have to actually hit bake before we can see it. So let me undo that. Nope, can't undo that. Clear that. So I did get rid of that thing, I think. So I didn't use that nav mesh at all. I went back to the original one where we selected the ground and set it to static. And if it's really complicated, you might not want to use the mesh links. I'll just uncheck that. Then our walls are all static objects. Those are the things we want to navigate around. So basically everything except the ground was set as walkable or not walkable. And then once we defined all those areas, I apparently forgot a obvious one, that we have to bake it in order to see it. For some reason, I thought the preview would be there before we baked it. So sorry about that. Extra confusing. So you just open the navigation pane, select all your objects and say whether they're walkable or not walkable, or define more areas as they would apply. And then when you're ready, you hit bake, and then that shows the area that we can walk around. So if I do the panning, you'll see that there's little gaps around all those walls where we can't quite approach the walls. So not walk the non-walkable area. And none of that blue highlighting showed up on the walls. So the computer knows we can't walk there. We can set different step heights. So that's what these settings are. Under bake, we can determine what sort of angle. Like maybe we can walk up to a 20-degree angle, which doesn't really apply here. The step height. How tall did I make those? If I make that 2 and hit bake, oh, I already defined them as not walkable. It would think our player could step up that high. So you'll just set up some settings of how high, how big of a step your character can take and the angle that it can walk up. Go through the other ones. So how far can it fall is the opposite of a step height. Like if it goes off a ledge, maybe that far is okay, but a 3-foot drop, your character is just going to stop and not consider that a ledge it can walk off of. If it needs to automatically jump, how far can it jump? How wide is the object it can jump over? And when you get all those settings, you bake that in place. And then you see the preview. Sorry, I was thinking that I would see the preview while setting those up and completely confused myself. Do have to hit bake before we can see it, but we can clear and rebake that over and over again. And then that shows the area we can walk around. So now over to the scripting part, the part that I thought was going to be a little bit harder. So just choose your meshes, decide whether they're walkable areas or not walkable. Add in things like steps and slopes and drop-offs and distances you might have to jump across, and all of those things that the navigation, the Pathfinder will need. And then when you're ready, send your hierarchy back to see where you can see everything. In the player object, we need a Nav Mesh Agent that we also have similar controls, like how fast is it going to move, how big is it, how tall is it, and all those different parameters. They're labeled nicely, so it kind of makes sense when we see them, and then we're ready to jump over and do our coding on that. So when we code this, so first thing I always do is put the curly braces back the way I like them and get rid of the text that doesn't do anything. So there's a couple parts we need. So we need, did I use event systems? I think that's something else in this example I'm looking at. We will need to use this library using Unity Engine.ai, which should seem obvious. We need the AI engine, and then from that we can create a nav mesh. It can be either way, public or private. Make it private because it's already connected to our object, so we can just ask for it, a Nav Mesh Agent. If I can spell, I'll call it agent, and we'll assign it with the get component method. And then we need a place for it to go. We have to say where it's going to go. And that is essentially transform data, right? Our transform tells us everything about the position, the location, the rotation, and the scale of everything. So whenever we want our character to walk somewhere, we need some location information to get there. So we'll set up some transform data, which I'm going to leave the private and public part off. You know what those do. We'll set up some transform data. I'll call it target. That's a good name for it. And that is where we want to try and get to. So obviously, to fill those in, our agent is just the get component. So agent is get component method, and just like we've seen before, it comes right off of our inspector over here. Our player has that Nav Mesh Agent component. Zoom thumbnails are in my way again. Those things just constantly stay in the way. And it is of type Nav Mesh Agent. So that gets us our agent. And the target will fill in here in a moment. We need a way to get to the target. But basically, once we have a target, we'll say if our target is not null. So if there is actually something assigned to that target value, then we'll just have the agent, and we can call the built-in set destination method to the target position, which essentially is just going to take the position of our player object and find the best path to get to that other position on there using those walkable surfaces we defined here. The stuff highlighted in blue after we hit bake. Which I'm pretty sure I'm going to remember that forever now. I have to actually hit bake. And stripped out of a trivial example like this is the obvious things like turn and face that target. And yes, it is. Did I spell it wrong? Oh, yep. My languages are running together. Python's none version of null has the capital N. So yes, null as in emptiness or void type of data. Electrically, that means we don't have a 1 or a 0. We left that circuit floating, which floating electricity shakes around a lot. So it's clearly not a 1 or a 0. That's how the computer can tell the difference. So in some sense, you could say it gives us a third state in the computer. Oh yeah, the color coding's nice. So that's the basic idea of it. We have an agent and then a target of where we want to go to, target position. Once we assign that agent, we can call the set destination and just tell it to go to the position of that target, which is just arbitrary transform data. But we need to fill that in. We haven't talked about it yet, but have you all encountered the word raycasting yet? Anywhere? We will talk about it in detail soon. Basically, raycasting is like a geometric ray. We have a starting position, and it's like a laser pointer. So a raycast is like a laser pointer. We're going to shine a laser pointer from some starting position, and when it hits something, that's the thing we're looking for. we cast out a ray and that's a perfectly straight line forever that we can filter down to our sorting layers and all that stuff like we do collisions. And when it hits something, that gives us another spot. So if we need a raycast, the easiest thing to get it is there's something else that we always have in our game that is always doing that all the time, right? If I come over here, wait for the compiler to run and switch to game view, which that's our camera, right? Which that camera is not in a very good spot. But a raycast is what that camera is doing all the time, nonstop. The raycast is just looks like I misspelled get component. The camera is just constantly sending out rays. And when it hits something, then it knows to draw that in its field of view and some other stuff. So since the camera is constantly doing that, which I should kind of fix the camera view so we can click in different spots, move it up and rotate it like this. That'll work. That'll work enough for our example. Get a better view. So we can use the rays from the camera to find any mouse click in the camera's line of sight. So that's the easiest way to set that up. Component. After I spell component correctly, we can make a reference to our camera. Whoops. We have some camera data called cam that we'll need to set because I want to show something that we haven't really seen yet. Actually, will that automatically be public? So we need to assign that. And notice, unlike when we make it public, there's no little field to put it here. So an alternative, like if we wanted to use private data and do that, so right before it, most people do it on the line before, we can say serialize field, I think is one word. Let me see if this throws an error. So as one word in Pascal case, and that puts even private data over here on the interface where we can fill it in. Which while we're over here, might as well drag this over and create the reference to our main camera so that we don't forget to do that after doing the more complicated part. I believe our book always uses the public version. That's what I usually do as well. But we can also do that with private data and use serialized field instead of the keyword public. There's the more than one way to do things. That's standard across the board. So whichever way makes the most sense in your mind. I think a lot of people prefer this way because it's more explicit than just saying public data and remembering the public data shows up. Explicit, make everything private, which is normally good form for object-oriented programming, and then explicitly state which ones we want to serialize. So that gives us our assignment. We could also do that because the camera is static, so we could just say cam equals main dot or camera dot main and refers to our main camera, but I wanted to show that serialized field thing somewhere. And now we can do our raycasting. So before we set come down to the update method, and we'll do this off the mouse button. So when we click, so if, actually I'll assign it somewhere. No, I don't want to assign it. I'll actually put it in the if statement. I was thinking it might look a little cleaner. Hopefully it'll make sense that that gives us a delay. That gives us a null pointer we might risk hitting if we actually assign it, because that won't be assigned every frame of the game unless we actually clicked. So we'll just listen for a mouse click right in the if statement. And again, we can use our input axis with get mouse button. And then we feed in an index and it goes from left to right. Mouses get complicated. So our indexes start at our left button, go across, and then down the left side and down the right side if you have the mouse with lots and lots of buttons. But our left click, the one we usually want, is going to be 0. So we'll get that button. And if that happens, we'll have the camera send out a ray to where that click is. This is the one I wanted, and this is the main reason I had the example pulled up, and I've been looking at it constantly. So we'll create a ray. I'll just call it ray. That's a good name for it. And it's going to be our camera, the camera reference we set up, our main camera here. Which would normally be following our player around, right? Maybe being used, controlled with the mouse as we move back and forth and up and down. The camera rotates around. So if we click somewhere, we'll get kind of indicate the spot we want to go to is what that's for. So when we click, we'll do a screen point to ray. A long name. I never seem to remember the name of that. So that is the main one I wanted to make sure and pull up the example for. So really that's the only thing I pulled up in the example. And input dot mouse position. Make sure I spelled that correctly. Get the thumbnails out of the way again. So our camera can do a screen point to ray and get the mouse position from the input whenever we do a left click. That makes sense? Get that out of the way so all the code fits. So if there's a left click, do a raycast to that position, which built-in command, all we have to do is ask for it. We don't have to worry about how it's put together. And then we can check and see if we have a raycast hit, which raycast hit is the object we want. And I'll call it hit. And there's a couple ways to do this. What I always do is call a static physics class. So we can say physics and it's a static class, so we can refer to that object directly. We don't have to instantiate it. It's static. There's one and only one, or in C#, it's a singleton. So then we'll ask for raycast hit. Raycast hit or raycast? Oh, just raycast. And then the parameters we have to fill are what ray are we looking for? That's the one we just called ray. Then the output from that ray needs to go into that hit variable. So we send out a ray and it might go forever. It might hit something, but whatever happens there, take the output from that ray, the result from that, and put it in our hit variable. And then there's a number. I can't remember what the number is. Oh, the number is the distance. Don't worry about something, only worry about some certain distances. So I'll put in a 30, but that's the distance. Our square was 25 by 25, so 30 would cover that whole square. We can click anywhere in that ground we made. But if you're in a big open world, you don't want your character to accidentally click on something that would be like 2,000 meters away. Right? That's that's further than one movement. We do steps to get several thousand meters like that. So our last number, it restricts that to a certain range. So that is a Boolean. You see why? If we send out an array and it says that something was encountered, that it does actually do a raycast hit within 30 of whatever our scale is, it's a true or false value. So it goes right into an if statement like that. And then we can do things like this, like set the target. If it hits something, then we'll set that target target.position is equal to hit.point. Because a raycast hit has lots of information, right? Actually, let me debug that. I'll do debug.log and actually pass in the hit. But like all of our objects, that's an object. It has lots of attributes about it. One of those is the actual point where that hit happened. We have the distance to it. We have the object itself that got hit. All sorts of information, which I don't think is going to all print out there, but that's the basic idea. So if we hit something when we click around, we'll set that to our target. And if target is not equal to null, then we'll move to that position or start moving towards that position. I think I got all the parts there, and only in about 10 minutes longer than I intended for it to take. Uh-oh. Did get a null reference. So what's our error? Object reference not set to instance of an object. Well, it says there was a raycast hit everywhere. So we kept getting that. What's the null reference? 2026 on line 27. Oh, target was never actually initialized, was it? Let me see if that was the problem. Oh, can't initialize it that way. What did I do in my example here? It's in a different script in my example. I have to jump over here. So target, we set that up. Target does not equal null. So that's what we're actually checking. Oh, let's see if that happened. Yeah, it popped up in the chat room that maybe that it's since it's down here, it's going to be null until we actually click somewhere. So I guess one thing we could do is vector 3 is a new vector 3 at 0, 0, 0, and target dot position is, oh, I need a name for that. Origin is set to the origin. Maybe that'll force an initialization. Unexpected character on line 16. Oh, where'd that come from? Well, I'm getting a hit, but it says it's still not instantiated. In the chat room, it popped up, set it to this. So target equals this dot trans. Target is this dot transform. Clear all this. Ah, there we go. So it's moving way too quick. But you can see it's kind of jumping around. So it's not null anymore. And yeah, that debug didn't help us. Put up with that. So that echo back to the screen didn't help as much. One of the problems is our, whoops. Our speed is way too quick. So speed of 3.5, let's try 0.1. Actually, you can change that while it's running, can't we? So why is it sinking down so much? That didn't help. You moved the ground at one point. You don't know if you moved the parent with the glider. Oh, I moved the ground. I don't think I meant to move the ground. Ground is there. Wait, is there not a collider on the ground? Oh, I put the box collider in the wrong spot. Let me go up to the parent object and add a box collider here. Which I cannot see where that's at. Oh, that is in the wrong spot. So that needs to be 25 by 25. There we go. And when setting things up, it's nice to have some easy numbers that you can code in, but once you get to the realistic situation, that usually doesn't necessarily apply. So it's still sinking in. It's still sinking in. If I do this, Just start the player way up here. I'm just starting too low. Nope. What if I turn gravity off? Oh, it turned back on. Okay, this is a weird effect. Clearly something got off of here. Oh, I think I did something really silly. Let's check that in the chat room. Where's the sphere collider on the player? Ground and ground image. So it looks like those are lined up, right? Our player has this collider. Oops. Which is right around if we scale it up a little. No. Okay, I'm gonna ignore that because I can get stuck tracking that down. We only have a couple minutes left. So back over here in the code, I think I skipped something. This one would probably shouldn't do that in the update. So I'm gonna move that down to a move method. Public void move. And it needs to take in some sort of transform. So, or really a vector 3. Vector 3 destination. I'll do it that way. And then we'll paste that in. So if we hit something, then instead of assigning that, I'm just going to call that move method and pass in that particular vector 3, which then sets our destination. And if we're not beside that, then we need to move there slowly. So in our update method, then we should, I think this will go a little bit slower. Let me see what happens when we run this. I might have to fix this stuff later. Oh, there it goes. But now our speed is just crazy slow. So back up to 3 like it was. We need to go over here. It just moves over to that point. Or if I click here, it has to actually go around stuff. Or back here. And you can see it's finding the best route. Sorry, there were a few mistakes along the way. I thought I remembered that, but I apparently forgot something important. And then if you think about it, you shouldn't have to think too hard to realize why that was a silly mistake to put that in the update method. Right? Because now we only call it when we click instead of redoing it every time. So it should be kind of obvious why that was just a silly mistake on my part, but I guess it gives you something to watch out for if you put in a Nav Mesh agent and see that happening. Remember to, we only need to set our destination once. We don't need to set our destination over and over and over and over again. So it gives us a better way to move. Now, our WASD keys and our arrows, the space, the shift, all of the normal ones. Yeah, all of the normal ones are there. The camera, if we wanted our camera to follow our player around and face it, we could get the camera panning by doing that. And then the back and forth of the mouse to zoom in and out, right? Those are kind of standard. Then all we need is that click. This one's not plugged up. Then all we need is that click in order to tell the character we want to move over here. Oh, whoops. Let me fix that speed issue. We want to move over there at a decent speed. I have no idea why it's sinking in the ground. It should be sitting on top of the ground. But if we want our thing to move from here over to say back here, there's a lot of obstacles in the way. So it has to figure out that S path to get all the way around there. And click over here, find its way there, or come way up here. And we can let the computer find the best route. So then the actual movement is handled internally, and all we did is click around. And since I forgot so many things, let's recap with what we did. So we need the navigation controls. So that's a separate panel. So we go up to Window and AI and open your navigation panel, which is over here by the inspector. And this thing we did not need at all. The video created that one we ended up not using. So I'm gonna take that out of there. When I couldn't remember things, you see it still works the same. So in our navigation panel, we go through all of our meshes, every mesh we have one at a time. So like the ground, that's static as far as our player is concerned. It's something we can walk on or walk around. And then all of those things get classified as either walkable, not walkable, or something we can jump over by default. And then we can add more areas, like we can say water or fog, different things. You can see we can keep adding. We can do 32 layers. So we can set up a whole lot of layers for different ways that we can navigate. And then once we're ready, then we go to bake, and you have to actually hit bake to get the preview. That's what I was forgetting. I was expecting to see the preview and couldn't find it, but it was really just have to actually bake in our stuff. We can set up how high of things can we step over, how tall, like how big is our player's legs. Do we have what are a couple standard mythical creatures? A giant, which would have human proportions, just really big, where they could make a really, really big step. Or ogres, which would be the same size as a giant, but an ogre typically has short legs and short arms, right? They're all body with just those short legs. So an ogre couldn't step as high as a giant, even if they were the same size. Hopefully that reference made sense, even though it was completely imaginary characters, but there are some standard typical things for those. How high can we step, and then what angle? So as our ground gets more interesting than just a flat cube, for a quick example, what angle can we walk up or down? Drop height is stepping down. Like how far are we going to let the AI jump off, right? We don't want to jump off a 50-foot cliff, but we'll jump off a 1 foot ledge, step off a 1 foot ledge. But so what's that limit? And then what distance can we jump? You set all that up, then you just hit bake to preserve that information. Then that's when we get the preview. And that's the thing I couldn't remember apparently. Then we clear our filters off over here in the hierarchy. So we can adjust that nav path, so enemy paths, that area. Then if yes. So we could also use this for enemy AI detection as well. Because we can set up different navigation areas, right? We have all those different areas. So some of these could be player walkable and other ones be enemy walkable. So that if the player goes into like the enemy walkable area, they see it and stuff. So a comment just popped up in the chat room about that. Adjust the nav paths, so enemy paths in that area. And then if the player steps in the enemy mesh, the enemy can get directly to the player. Or if you look at the official Unity documentation for it, their example is walking around inside the house. So it has things like going up the staircase, but not underneath the staircase, and walking around furniture and stuff like that. Lots of different control. We set all that up, then bake it. And then in our actual player, there's a few options there. Query nodes are probably what would relate to that thing that was just in the chat room. But we're down to 4 minutes to our time schedule, and I want to try to review everything. So our player gets a Nav Mesh Agent component where we get obvious things like speed, acceleration, the sizes of all that. And then in our script, we have to do raycasting to find that click point. And our camera is always doing raycasting all the time. So we can just use one of the camera's rays along with a reference to a Nav Mesh Agent. And I got rid of that transform. We just did that a different way. We just used it directly. So we need the Nav Mesh Agent in the camera, the most stripped down example. Then if we left click, or whichever index of your mouse you want to use for that, we call this method from the camera to look at that mouse click. Then we set up an empty raycast hit, which we can fill with this static method that is a Boolean, so it goes right in our statement. So this raycast, the camera sent out, if the output of that fits in to a raycast hit variable, which means our ray hits something, and we're only going to go out 30 of our units. So however many units when we go out, then we'll pass the vector, vector 3 position of that mouse click or that raycast hit to a method that sets the destination for our Nav Mesh Agent. Sorry, I apparently forgot a couple things along the way there in my example that I'm looking at for a couple, because I knew I was going to forget. This one was really, it was a huge role-playing game. I probably could have done a more stripped down example. Hopefully those things that kind of threw my memory off there while we were doing that didn't make it too confusing, but those steps give us a really nice thing. Uh-oh, where else is targeted at? Oh. I think that'll work the same. Yeah, so we didn't even use that transform data. That was overkill on there. And we just click and it will automatically find the best route to where we want it to go. A very, very useful way to navigate around the world. And it frees up a whole bunch of other buttons for us to use. So a lot of information this evening. That one was not included in the book. Do y'all want me to send that example out after class? Or were y'all following along? Okay, I see a thumbs up, so I will send that out right after class, which it's 8:49, so that kind of ate up all of our time. Does anybody have any questions about stuff for this evening? And the last minute here. I'll give it a few seconds. Okay, I assume the silence means no questions. So I'll see you all on Wednesday and we'll continue with an example then. And I will make sure and review everything so that it's more fresh on my mind. So y'all have a great night. I'll send that example out here in just a moment.